In question number 7, they have given us two equations for velocity of an object which is going in a straight line. There is this equation for from 0 seconds to 15 seconds, and this is 15 seconds and more. So can you notice here there's an equal mark here and there's an equal mark here. It has a very big significance. It shows that these two equations are equal at 15 seconds. If we need to equate them sometime, we will equate them at 15 seconds. Both of them are same. So let's go to the question. They have given us a situation also, t equal to 0 and t equal to 15. Between them the distance traveled is 225. Distance, that is the key word, distance. The equations we get are for the vector quantities, velocity and displacements, but here they're saying distance, so we have to take care of this, that there is no turning point. We'll take care of this also. First part says find the value of A and show that B is this. So what will we do? We'll find the value of A first. So since we have been given a distance of 225, so we'll convert this equation, first equation, into displacement equation. Let's do that. So to convert it into displacement, we will integrate them with respect to time, both sides. On the right side, A is a constant, so we will write E minus 0.05 t square dt. Okay, so when we integrate a velocity equation, we get displacement. And A is a constant, keep it like this, but we will integrate what is inside. So P will be t square over 2 minus 0.05 t cube over 3, and there will be C extra. Let's see how can we find C. Is there a hint before this? So they have written velocity is t seconds after the vehicle starts. So that means when it starts, it has 0 distance from the starting point, and the time is also 0. So 0 square over 2 minus 0.05 t 0 cube over 3 plus C. Since this is 0 gone, this is 0 gone, and A multiplied with 0 is also 0, so C is 0. There is no C. Okay, so our equation for displacement in first 15 seconds becomes d equal to A t square over 2 minus 0.05 t cube over 3. Now, since it's a quadratic equation for velocity and cubic equation for displacement, there's a possibility that it is going in the straight line, but it's a possibility that it went, took a turn, came back, took a turn again, and then like this. There could be a turning point in which will change the distance, and we can't use 225 if there is a turning point between 0 and 15 seconds. If there is a turning point, then we can't use 225 easily. So let's ensure that there is no turning point. So what will we do? We'll find that when is the turning point. At turning points, velocity is 0. So let's make velocity 0. 0 equal to A, and let's take t common from this. T, and remaining will be 1 minus 0.05 p, right? So A cannot be 0, it's a constant, so gone. T is 0, that means it is turning at t equal to 0, so that is not a danger for us. Let's say what it gives us. It gives us 1 minus 0.05 t equal to 0, so t equal to 1 over 0.05. That's how, yeah, if 1 goes there, negative, it becomes 20 seconds. Alright, so there is no turning point before 15 seconds, so we don't have to worry. We can use 225 easily now. So let's use it. 225 equal to A, unknown, but we know time now, 15, this set, right? At 15 seconds, it was 225 meters. So 15 square over 2 minus 0.0515 cube over 3. So A will be 225 divided by 15 square is 225 over 2 minus 0.0515 cube over 3. Let's put this whole thing in our calculator and we get the value of, let's put it back again, A equal to 4. 4 is the velocity. 4 is the value of A. Now let's find the value of B. That's what they're saying. Find the value of B also. So now we said that this velocity and this velocity can be equated at 15 because both have equal mass. And practically also an object does not vanish at a certain point, right? If it was at 15, suddenly it becomes 100 meters per second. Not possible. So we'll equate the two equations. First equation was A t minus 0.5t. So first equation is A. Now we know A now. 4 t minus 0.05 t square will be equal to B over t square. And we know it is time 15 when we can equate them. No other time we can equate. So we'll write 15 minus 0.05 15 square equal to B over 15 square. So 15 square will go and multiply here, times 4 will be 900, 225 times 4, 900, and 15 minus 0.05 15 square equal to B. And if we put this in our calculator, we must get 3375. That's what they're asking us to show. In second part, they're saying that find an expression in terms of t for the total distance traveled by the vehicle when it is t equal to t is greater than 15. So we have to keep in mind that since greater than 15 we have a reciprocal function here, there will not be any turning point. There will be only asymptotes, and which cannot be possible with a physical object. So we don't have to worry about the turning points. We'll straight away integrate this. So let's integrate v dt equal to b is 3375 and 1 over t square dt, right? I separated b and 1 over t square. So let's integrate. V dt gives us displacement equal to 3375 and 1 over t square can be written as t to the power minus 2. So if I want to integrate, it will be plus 1 here, minus 2 plus 1 here. So it will become minus 2 plus 1 minus 1, right? So divided by t, and this will be minus 1. So there will be this minus in front and plus c. To find c, we know that at 15 seconds it was 225 meters away. So we can use this fact to find c. So 225 equal to minus 3375 over 15 plus c, which is 225, and 3375 divided by 15 is also 225 plus c. When this goes there, it becomes 225 plus 225, which is 450. So c is 450. So this equation becomes displacement equal to 450. Let's write c first, and then 3375 over t. This is the expression in terms of t for the distance or displacement, in this case more than 15 seconds. Okay, the final one, part 3. This is part 2. Find the speed of the vehicle when it traveled a total distance of 315, and since it is more than 225, that is, it is more than 15 seconds, and we don't need to worry about again the turning points. Straight away use the distance formula, and distance formula we just got it, 450 minus 3375 over t. So 315 is the displacement, and 450 minus 3375 over t it was the formula, I used it. So let's bring it to the other side. 350 minus 450 minus 135 equal to minus 3375 over t. So t and 135 will exchange the places. T equal to minus 3375 over minus 130. These two cancel and it comes out to be 25 seconds. So 25 seconds later, the distance traveled was 315 meters. All right. Here you might be thinking that there was a turning point at 20 seconds we just found in the first part, but that does not apply because the equation has changed after 15 seconds. So we don't have to worry about it. So they're saying find the speed at this time, at 25 seconds, what is the speed? And we know the equation, they have already given us v equal to b was 3375 over t square. Let me check. Yeah, t square. And t square is 25. We know 25 seconds now. Make it square and that will be 5.4 meters per second.